equal and opposite reaction, because this is slowing down, it's going to keep going in the same way. But if you don't have the same amount of energy going into it, it's going to slow down. Okay, go ahead. Next one.
I don't want to go to a
What is that picture illustrate? And thank God for static equilibrium. What it says is there's no net external forces acting on this platform. You know, people go out there and work on these things for days, for months, because they're out there digging for oil.
How do they
So
that?
it's good that there's no external forces acting on it, because what would happen to it?
It would tumble down to the bottom of the ocean.
Yeah, it would lean over, because we're talking about equilibrium. Things that are in equilibrium.
Titanic would do it. I'm sorry. I'll be quiet.
What we're talking about is forces. We want you to be more technical with your thinking.
Yes, ma'am.
And your communication.
Yes, sir.
Okay, so go to the next.
Messing with West.
Okay, go ahead, David.
Transitional equilibrium, which there are no unbalanced forces acting on a body.
That's what we're talking about. If those forces are unbalanced, will make a structure unstable. Look at this first picture on the left-hand side. Balance. What about on the other side? Unbalanced. So what's the cause of it?
Gravity.
Bad architectural design.
It could be, but let's look at this in terms
But it ain't.
of let's look at it in terms of forces.
Shut up, Eric.
The forces are acting on it, causes an unbalanced state or a state of not being in a static state of static. When the forces are all equal, for example.
What is the banana? Fresh banana.
You don't have a test on it. Be quiet.
When's our test?
Oh man.
What does this stand for right here?
Fresh banana.
What's that big symbol? It's a Greek symbol. What does it stand for?
Omega. Fresh banana.
No, Omega.
Fresh banana.
Equilibrium.
Omega is a big old star.
God of War. God of War.
Olympus. Arlene. Holmes. What's up?
No, it's not Delta.
The Holocaust.
Alpha.
Okay. Stop and be quiet. Be quiet. It stands for sigma. Capital letter is the Greek alphabet. Sigma. Sigma, which means, pay attention so you can learn and quit acting silly. Stop all that, Justin, because it's distracting.
Quiet.
So you can learn something so people can listen to you and talk to you. Quit acting silly. Okay, it's a Greek letter, capital Greek letter for sigma, which stands for what? Who knows?
Ninja Gaiden.
What does it mean? What does it mean?
Ninja.
It means to sum it up. Whenever you see the Greek letter sigma, capital letter sigma, it means to sum it up. So what this is saying right here, sum up the forces on the x-axis right here is 0.
Look like a
and
giant
if I sum up the
possum.
forces on the y-axis up here is 0. So
A
0
human
equals
possum.
0. Would that be a state of static equilibrium? Yes or no?
Yes.
Yes.
Because it's equal 0, 0.
Because it is balanced, right?
Yep.
What if the numbers were different?
No equilibrium.
No equilibrium. Good. So it'd be more like this.
Retainer.
So that's what this is saying in a technical sense. Okay, go to the next one. Okay, go ahead. Who was reading? Dave? Dave, you finished? Okay, go ahead, Tevin.
It's mine. Me.
Okay.
Haina Bahina.
Go after you, Kevin.
Pinocha Mahara.
He was after Tevin.
Pinocha Mahara.
Go. Okay, who wants to take the house? Okay, go ahead, Tevin.
Eight.
Record for now.
Okay, so what's that symbol in front of?
2.
And that means what?
Add it up.
Sum it up or add it up.
Oh, I thought I was wrong for a second.
Okay, what's the capital M for? What's the capital M stand for?
Penultimate.
Moment.
Penultimate.
Moment, which is 4 times this.
Stand for penultimate.
And what do they say? They say
It's equal to 0.
High of hina.
Where is this? Which
Football.
direction is this?
Clockwise. Counterclockwise.
So if these two equal what? 0, it'll be what?
Equal.
Boom,
It'll
boom.
be in
Balance.
the
Boom,
state
boom, boom.
Rotational equilibrium level.
There you go. That's it. Okay,
Oh!
go on to the next one.
Got it.
Bagale. Whoop, got it.
Okay, go to the next one.
Whoop, got
Good
it.
job, Carl.
Peace up.
Okay, keep reading. Serious too. Who else supposed to read it?
Justin.
Okay, go ahead.
Louisiana.
Justin Timberlake.
Static principles.
Go ahead,
Scalar quantities.
Go ahead, Kevin. You reading too. Go ahead, read this.
Yeah, because he from Louisiana.
You're going to see this also in physics. A scalar quantity versus
It's a ghost.
vector quantity, which will be next. A scalar quantity is like we look at how much you weigh.
Fresh
We don't
banana.
say it had, we talk about magnitude, the size of it, how big it is. So we say that
I am a banana.
in your weight is 100.
I am a banana.
That's the magnitude only. That's like mass. We also look at speed as magnitude only. How many see your parents drive? What's the average speed
I
they
drive 65.
65. 90 miles. If you say you're going 65 miles per hour,
120.
that's a scalar quantity. But I didn't tell you didn't tell me what direction you were going in. You just told me how fast, right?
My
So
teeth
that's why
hurt.
it's considered a scalar quantity. Go to the next one. Now
My teeth hurt.
I drive like
My turn.
Okay, go ahead, Justin.
That's why I talk like this.
Static principles. Vector quantities. A quantity of magnitude and direction. Example: position, velocity, force, and moment.
Okay, let me give you this other. Let's look at wow. If I say that George's parents was driving 65 miles per hour in the northwest direction, now I describe that quantity as a vector quantity because I've given you direction and magnitude. I told you how fast he was going and what direction. So that's a distinct difference between those two quantities. And temperature is also a scalar quantity. Because we don't say it's 70 degrees southwest outside, do we? We just say how
west.
hot or cold it is.
Hina, vahina.
But in velocity, we can describe
Vahina,
it in
vahina,
terms of
vahina,
how
vahina.
fast we're going and what direction we're going.
can go
That's the
possum
difference. Okay, go to the next one.
We can go possible.
Okay, and this is an example of. Go ahead,
I'm
Justin.
done.
What is force? The pushing or pulling interaction of objects. A vector quantity is
Bye, everybody.
magnitude, direction, and point of application.
Okay, what would be the